Welcome to Tattva Conversations and Explorations. For our seventh episode on physics, we sat down with Mr. Tom Campbell. He's a lifelong professional applied physicist who began a parallel career in the early 1970s, researching altered states of consciousness with Bob Monroe at the Monroe Labs. In February 2003, Mr. Campbell published the My Big Toe, My Big Theory of Everything trilogy, which represents the results of over 30 years of scientific exploration into the nature of existence. In 2016, he presented a set of quantum physics experiments designed to provide evidence for or against the hypotheses that a reality is virtual and that consciousness is the computer. Currently, these experiments are being performed at the California Polytechnical University. First results are expected in 2022. My conversation with Mr. Campbell showed me how closely and deeply consciousness is linked with physics and perhaps everything else. While we did get to talk about what physics means to him and his own approach to it, most of our conversation revolved around his understanding of the nature of consciousness and our reasons for being here as individuals and as a part of a collective. We hope this conversation can help the listeners see the tattva, or the true essence of physics, and the important role it plays in helping us understand the world we live in and appreciate the fundamental forces that lie underneath everything. Hello, Mr. Campbell. Welcome to Tattva.
Well, thank you, Disha. I'm pleased to be here.
We're very happy to have you, Mr. Campbell. And I just like to jump right in with all my guests. So I've prepared a bunch of questions for you. And Shall we just get right to it?
Let's just get right to it. Yes.
Great. So my first question is the most obvious one. And it is, I want to know from you what physics is about, and if you can describe your approach to the subject.
Okay. That's an interesting question, one I haven't been asked before. So off to a good start. I like questions that I haven't been asked before.
I'm sure.
Physics is the business of modeling reality. Okay. Modeling reality. Now, the model is not the reality, but it's us trying to understand how reality works. So that fundamentally, in my mind, is what physics is about. Now, physics is required to be logical. Because if you're going to model something, it needs to be a logical model. The model needs to make sense. It can't be just random models. And it's better if there are fewer assumptions. There's a better model if there's fewer assumptions in the model. And it's a better model if it is simple and elegant, as far as describing things that are fundamental.
Right.
So there's many things in physics that aren't fundamental. They're just, what can we say, logical consequences. And sometimes deriving the logical consequences get very complex and very complicated. But the fundamental understanding of the nature of reality should be simple and elegant and logical. Okay, now, modeling reality has used the language of mathematics a lot. So we often think of physics as almost an applied mathematics, taking mathematics and applying it to describing what we call the real world, the actual physical world we see. But mathematics is not a defining component of physics. It's just a tool that physics uses.
Right.
Logic is a defining component of physics or of science. We just talk in general science, because after all, physics is at the very bottom of the logical bottom, the logical foundation of all the rest of the sciences. You start with physics, and then on top of physics is built chemistry, and on top of chemistry and physics is built biology. So physics is kind of the root. How does reality fundamentally work? And we make models of reality.
Right.
Now, it's important to know that the model is not the reality, and that models are to be judged solely on their ability to logically explain reality and how it works. Okay. So, and that model, like I say, should have as a few assumptions as possible, and should be as simple and elegant as possible. So that's my basic look at physics. We physicists are about modeling reality.
Sure.
And the models need to be useful. They need to be able to make predictions and give explanations. We explain everything that we know. We should explain all the facts. Now, what makes a fact? In physics, a fact is something that is verified by an experiment.
Right.
By multiple experiments, by multiple people in multiple places. And if you have that, then that defines a fact in science or in physics. Now, the experiment can be very simple. You can just pick up a rock and turn your hand over and the rock falls down. You know, it always goes down. It never goes up. That could be a simple experiment. But so that's what defines the facts. So we try to explain with our models all of the facts that we know, and we try to generate new facts, new understandings. So the theorists in physics say, well, I think if we did this experiment, we'd find this fact. And then the experimentalists in physics go out and do the experiment and see if indeed you do find that.
Sure.
So that's typically the way the science works. Sometimes it works the opposite. The experimentalists find something and say, wow, this doesn't make any sense. You theorists have any idea why it's like this? And then the theorists make up a story to try to describe why it's like that. So it can work both directions. But typically the theory leads, and then the experiments tend to try to justify or deny, the theory, whether the theory is right or not. Now, we in physics have given up, back not that long after Newton, or well, I shouldn't say that, in the early 1920s, we gave up thinking that we knew everything. With Newton, we talked about Newton's laws, and then we realized that Newton's laws really weren't laws. They were only applicable to a subset of reality.
Right.
That part of reality that doesn't move too fast and isn't too small,
Right.
Or even too large for that matter. So it didn't apply everywhere. So they really weren't laws. And we kind of lost that arrogance then. And now everything is theory. So we talk about the quantum theory,
Right.
Relativity theory. We don't talk about the laws of quantum physics and the laws of relativity. Everything is theory, but in theory, we don't mean our best guess. We mean our best model, our best logical model. That's the theory. So it's a good question to ask because it's important to understand that these theories or models, and I use those words interchangeably. A theory and a model are pretty much the same thing.
Right.
They don't have to. They don't have to be well liked. They don't have to even make sense. They just have to work. It's just important that they can deliver. They can explain. Matter of fact, as we have gone through multiple paradigm shifts, we realize that often the new, better theory that creates a paradigm shift, from the old theory, when that new theory came out, it sounded crazy, like relativity and quantum physics both. They sounded just a little goofy to the understanding that physicists had before. But then eventually they become mainstream.
Right.
But they start out as being strange, probably sounding wrong because they aren't explainable by the old paradigm. They kind of bust out of the old paradigm. So anyway, that's the nature of physics. It changes. It's not done. And new paradigms are in the wings coming along. And most of the work that I do is toward a new paradigm in physics. So,
Wow.
That answers
that's
your question.
certainly, certainly. It really gives it a much better picture than I think when I always go back to my school time when I'm doing these interviews, and it would
Mhm.
most of these subjects which is thrust upon us. So you reach a certain standard, you reach a certain class. Here is physics. You reach a certain class. Here is biology, and
Mhm.
you just get on with it. You're never really told what you're studying. Yeah, you get a sense there are plants here, there is some Earth here, there is some planet there, there's something there, but you are not able to really get in under the skin of the subject, so to speak.
Mhm.
So it always remains a mystery, even if you are ranked number one in your class. It remains a mystery, and I don't mean it mystery in a
Mhm.
big sense, but like, what did I just study? I know the theory, I know the formulas, okay. So this makes it gives it a form that I can relate to. It resonates. So
Mhm.
now I'm sure now you've been doing what you've been doing for a really, really, really long time, and this understanding emerged with time. And how would you
Mhm.
say your own approach to this subject of physics has been? Like, how did you approach this when you started out, and over time, has it evolved, has it changed?
Well, yes, it's evolved and changed a whole lot, but let's start at the beginning. Even as a very young person, I was inclined to science and perhaps engineering. One of those people that takes things apart.
Mm-hmm.
When you're 5 or 6 years old, everything that can be taken apart is taken apart and then put back together and so on. Just interested in how do things work and why do they work that way. So that was always just part of my mindset. It's kind of the way I am.
Mm-hmm.
So that kind of was a natural for me to go into a technical or a scientific field because that's how I'm made. So I was I studied physics in college, got a bachelor's degree, then a master's degree, and then worked on my PhD. So I've spent a long time studying physics.
Mm-hmm.
And when you get to quantum physics, it's always difficult because you suddenly leave the realm of intuitively understanding how reality works to one of it's just the math. Don't try to understand what's going on or why it's going on. Just do the math and get the result.
Right.
Matter of fact, that idea was made famous by Feynman with a statement. He said, just shut up and calculate.
Mm-hmm.
When asked by his graduate students, what's happening here, Dr. Feynman? And he said, shut up and calculate.
Mm-hmm.
So I was open-minded in the sense that I knew that reality seemed to have some mysteries, particularly in the quantum physics area, that we just didn't understand very well
Mm-hmm.
because quantum physics was called weird science.
Right.
It's still called weird science. And that did not sit very well with me because I don't think science is weird. Science needs to be logical. It needs to be rational. And to me, when science is weird, it means that we don't understand it.
Mm-hmm.
There's something about it that we are missing. There's a paradigm shift that we need to understand. And once we understand it, it will become simple. Oh, that's how it works, sort of thing. So my thought was that. So I always had that in the back of my mind. But I was the typical physicist that thought reality was defined by measurement. It was defined by, what do we call it? There's a name for that, a philosophical name for it. But basically, it is that reality uh, only exists in as much as you can interact with it. Okay, if you can't interact with it, if you can't touch it, or somehow manipulate it, or feel it, or see it, or
Mm-hmm.
if there's no way for you to interact with it,
Mm-hmm.
then it's not real. It's imaginary. It's something else. So you have to physically interact with it before it can be real. Okay, now that's um, I almost jumped in my mind, but it left me again. But anyway, there's a name for that.
But are you saying something like how they say if the tree falls or makes a sound in the forest, uh, does it did it really happen or not? Since you were not there, is it something like
Yeah,
that
well,
you?
it's something like that. What it says, I got it now. It's called an operational definition of reality. An
Mm-hmm.
operational definition. If
Right.
you can't perform any sort of an operation on it, which means see it, feel it, touch it, somehow sense it, then it's beyond our physical ability to examine it. And in that case, it falls in a category of either it does not exist or it is not important. Everything that exists and is important is something that you can interact with, you can connect with, you can perform some kind of operation with it. And most physicists feel that way. It's wrong, but most people feel that way. I learned that is not correct. But that's kind of the standard materialistic viewpoint that physics brings to their models. And they kind of force their models into that realm. And as soon as you get outside of this objective space, then physics says, not in our, it's not in our lane. We don't do that. So if you talk to them about consciousness, they'll go, that's not solid. That's mind stuff, and physics just is about the objective world, just the world you can measure, just the world you can interact with, which is a shame, because the most significant part of our life is internal. The most significant part of our existence is in the subjective part of our world. That's where the love is. That's where the caring is. That's where relationships are. That's where justice and, all those things are not objective. They're all subjective things. Important things, the big decisions in our life, like who are you going to marry? What career are you going to have? None of those things have an objective answer, you see? So physics removes itself from that part of reality that's really most important to most people most of the time. And that's a shame. Physics and its understanding and its models can go farther than that, but they don't. Actually, there is a science of the subjective, which is part of what I have been doing. So what I've been doing is coming up with a model, physics model of the nature of reality, as physicists do. And this model can explain everything that is objective, and it explains quantum physics without it being weird. It explains quantum physics as a logical science, and it explains relativity. You can derive, I guess I should say that, you can derive both quantum physics and relativity from this understanding. And the model I have is basically a model of consciousness. And I'll tell you in a minute, I'll go back kind of to the beginning of where all this came together. But this model of consciousness is really a model of the subjective world. And it is a scientific model. It starts with, it has assumptions and it has a lot of rules and things. And it is a logical model, just as any science should be. And the same logic that explains consciousness will let me derive clearly quantum physics and relativity. So we see that the objective world is really just a subset of the subjective world. There really is no objective world. The objective world is only approximately objective when the uncertainty is small. So now let me explain that. If you measure something, let's say we just take a brick, just take a normal brick, building brick, and what is its volume? How long is it? How wide is it? How tall is it? Well, there is no absolute answer to any of those questions, because eventually we run out of our ability to measure it and more finely. You see, so if you put 10 different groups of physicists to measure that brick, and they had instruments that would measure down to maybe an X-ray or maybe a wavelength of light. But eventually they get to a point that they say, yeah, it's this plus or minus something else. In other words, we don't know exactly what it is. Matter of fact, how do you measure the length of a brick when the side of a brick down at the molecular level is real bumpy? It's not a flat surface. Do we measure to the top of the bump or to the dimple inside, because that brick surface isn't flat, it's all kind of lumpy. And for that matter, those lumps come and go. The molecules are in motion. The the volume of that brick isn't even defined, isn't even the same from instant to instant. It changes. So when the uncertainty is small, like it is with that brick, we're talking about the unknown is down in the 10th or 20th decimal place, perhaps, then we call that objective. So the world where the uncertainty in that world is very small, we call that the objective world. But there's still uncertainty. There's still randomness. And where there is uncertainty and randomness, you cannot have basically, an objective. It's not entirely objective. It's only approximately. It's only approximately objective. So our world, our objective world is really a subset of a bigger idea, of a bigger concept. And Einstein spent the last 20 years of his life trying to come up with a TOE, theory of everything, TOE, because scientists then and now know that quantum physics and relativity are incompatible. Each one has something that it must, a logical premise that it accepts that is denied by the other. Wow. So they just have a problem. And what that told, a conflict, a logical conflict. And what that told physicists, what that told Einstein and all the physicists is that there's something else at a higher level of understanding that derives both. In other words, these two things work in their own area. Relativity, works here and quantum physics works there. And between the two of them, we just about have all of our approximate objective reality covered, but they don't really get along that well themselves logically. So there must be some other understanding at a higher level that will derive both of those things. That was the TOE that Einstein tried to come up with. And after 20 some years of working on that, he failed. He could not come up with something that would derive it. Now, he made some very interesting comments about his search. One is that it has to have something to do with consciousness. Einstein said things like that. So did Planck and Wigner and a lot of the top scientists at the time. They realized consciousness was a player because their quantum physics told them that, but they had no idea how to quantify that, how to make that into a science. They were just kind of stuck there. And that's the TOE. But now what I have come up with is what I call a big TOE, because what Einstein was working on was a little TOE. It just wanted to find the overarching explanation for both quantum physics and relativity. And my TOE is a big TOE because it also comes up with a scientific, logical explanation of the subjective as well as the objective. So the objective is basically quantum physics and relativity. That covers the objective world.
Right.
And we don't have anything that covers the subjective world as far as science goes. We've got a lot of bits and pieces, lots of theories and lots of bits and pieces of things, but not any overall understanding of how that is. So let me back up a bit. You say, how did I get there? And I'll start with that. I kind of jump to the end of where it is, what it is I'm doing here.
Sure.
And I'd go back a little bit to the beginning. When I was in graduate school, I learned how to meditate because I thought I could get by with less sleep if I meditated. It was just that simple. I was a graduate student. I'm working on my PhD, and I worked with this big Van de Graaff generator that had, was very complicated and worked some of the time, but not all the time. And when it worked and you were taking data, you stayed with it 24 hours a day taking data, because when it stopped working, it might be 2 weeks before you got it working again. So you had to, once you got on, and we had to share, of course, this big machine, a bunch of people shared time on it.
Sure.
So when you got it, and if you had it working in your time slot to do it, then you didn't sleep. You just kept working, for as long as you could, till your time slot was up or till the machine stopped working. And in any case, so I saw this ad that said transcendental meditation, and it listed a bunch of things that you would get from it, and one of them, get by with less sleep. So I said, good, I'll go do that. But I found out that when I started to meditate, it was just a natural. It just, meditation was very simple for me.
Wow.
And just instantly I was gone. And I'd come back later and think maybe 5 or 10 minutes was gone, and it's like an hour had passed.
Wow.
So I very quickly took to the meditation. And about 3 or 4 months in of meditating, like they asked me to twice a day for, I think it was a half an hour each time or 20 minutes each time, I found just by accident that I could debug my code. I had to write all the code. You know, in those days, the university, the computer that served the whole university probably wasn't as powerful as your cell phone. You know, it was huge, and it took up a whole room. You know, there was a whole building that this computer took up, but it probably wasn't as powerful as your cell phone is today. And the whole university had to take turns using this one big mainframe computer. Matter of fact, it was a Burroughs computer running Algol, and that doesn't even exist anymore in this world. So being able to debug in those days was very difficult. It wasn't easy like it is now. And now the software actually helps you debug. It tells you where the program went wrong and at what statement, you know, it was not correct. And we got lots and lots of help now because the computers are much more sophisticated. But back in that day, it wasn't like that. You put your data in, talk to the computer through punch cards. And those punch cards were just cards with little holes in them, and the light would shine through the holes, and that's how the computer translated what you intended it to have in the statements that was in its language. So one of your main errors could be just the hole in the punch card was a little off. It was a 0.5 millimeter out of line because the punch card machine was just a big machine, and it obviously got out of the line, and had need maintenance and that sort of thing. So errors were really hard to find, and you only got one run probably a week because you were sharing it with a lot of other people. And if that one run, basically what the information you'd get back is it didn't run, it bombed, period. You didn't get any information of where or why or how. It just, we started it, it didn't run. Here, you know, come back later. So if you only get one chance a week to find out, you know, to try to debug your program, you could see debugging programs was a very, very important step that we kind of take for granted these days. And I found that when I was in my meditation state, I could see my printout just scroll by me, and the lines of code, of course, were all familiar to me because I'd written every line of code. You know, graduate students do all their own programming, of course. And the lines that were red instead of black, I checked those out, and those were the ones with errors. And I discovered I could debug my code just by bringing up my printout, letting it scroll by, and noting where the red lines were. Then I'd go up to my decks of cards, find the card where that statement was, and check out the card and see, oh, did I leave I didn't put a comma or a semicolon at the end of the line, or, you know, was the whole punch kind of ragged on one side? And I found that all those things were right. And I could debug my code 1,000 times faster, which means I got a lot more done, you know, with the computer. And that changed my idea that this reality was just what you could measure, what you interacted with. That, you know, and I knew that there was something else that had to do with mind, had to do with consciousness, and there was more to reality than what you could measure, what you could interact with physically. And I wanted to understand, what is it? How does it work? You know, I'm a physicist. I wanted to model it. How does it work? What can you do? Well, I knew I could debug code, but what else could you do? And why could you do it? And why was it easy sometimes and not as easy other times? You know, I had all these questions about it that as a physicist, I wanted to understand. And when I left the university, took a job, and within a very few months, I ended up connecting with Robert Monroe, my boss of all people in this job. The job was technical intelligence. And I was a physicist among other scientists and mathematicians and so on that worked in this technical intelligence place. We looked at foreign technology to see whether we could learn anything from it, or when we were looking more for the military, we were trying to find out, oh, this is a weapon that our adversaries use. How can we beat it? What is its Achilles heel? What is its weak spot? How do you go about destroying it? So we were doing those kinds of things. That's what technical intelligence is, intelligence about the technology that others have and what you can learn from it, and if it's something you need to defeat, how do you defeat it? So I was in that business, and my boss introduced me to Robert Monroe's book and asked me what I thought of it. And I read it, and what maybe your readers don't know, but Robert Monroe wrote Journeys Out of the Body, Far Journeys, and Ultimate Journey. He was a guy who had out-of-body experiences spontaneously and didn't want to have them. They scared him to death, but he had them anyway. So he started just keeping notes, like a diary of all the things that happened to him. And that diary then became a book. So I looked at it and I told my boss, I said, well, if this is real, then wow, because I know reality is bigger than the physical, but is this real, or is he just trying to sell books? My boss tracked him down, found out he only lived about an hour away from the city we worked in, and we made an appointment to go visit Bob Monroe. And I wanted to know, is this guy just hustling and making stuff up to sell books, or are these events he had real? Because his diary was fairly complete about all the things he could do, information he could get, ways he could interact with the physical world. So when I met Bob Monroe, he had just built a lab for studying consciousness. And he was a serious guy. He wasn't an engineer, but he had a personality like an engineer. He was very factual, very matter of fact, a good mind, smart guy. And he didn't want to be the crazy old guy who had, unusual experiences. He wanted it to be science. He wanted it to be legitimate, that people wouldn't just think he was crazy, but people could see that he was doing something that was real. So he built a lab. He was wealthy, and he built a lab and wanted to study consciousness to help understand this phenomena that just happened to him. So I happened to be there, a young physicist at the time. I was in my 20s then, middle 20s, and he built the lab, but he didn't really know what to do with it. He didn't have anybody to man it, or didn't know what kind of experiments to do. He was kind of lost. So he was looking for some people to work in his lab, and I was looking to learn how to understand consciousness better because of my experiences with the debugging. So we made that connection. So for the next almost decade, I spent anywhere from 15 to 20 hours a week with Bob Monroe at his lab, doing research. And Bob was a good teacher. In probably a year and a half, I also was going out of body whenever I wanted to, on demand, not just randomly, but I could put my mind in the right mind frame that I could then do the same kind of things Bob did. So also another friend of mine who was an electrical engineer also worked with where I did in technical intelligence. He was part of that group too. So he and I came out and spent a lot of time in the lab with Bob working on trying to understand, doing experiments. We wanted to make it something that you could teach other people, to let people know that it wasn't just some special weird people, did this, but that you could learn it. It was something that was learnable. So we were working on that, and I was trying to make it precise that I could go out of body. Now, out of body is a very bad term. You're not going out of your body. There's nothing in your body. That's just the terminology, but it's very inaccurate. So I got to the point that I could what I call now just explore consciousness, which is all it was. It wasn't really going out of body. It was just exploring your consciousness. That I could explore the realm of consciousness very precisely. I could get in the same altered state of consciousness, and I could do science there. I could, we learned how to do lots of paranormal things. We could remote view. We were using our minds to heal. We were practicing, just playing, really. We're just playing with what can you do, and what can't you do and why, coming up with that sort of thing. So we tried to do things that were evidential. We tried reading newspaper headlines a week before they were published, to see whether we could see the future. We did a lot of remote viewing, trying to see what was at some remote place and then see whether or not we got it right. So we just did lots of evidential things, and the healing and telepathy, mind-to-mind talk, communication. So we worked at these things, and at the end of a couple of years, it was clear that these paranormal things were real because we both had done it thousands of times, and it was repeatable, and it was perfectly clear that it was real, but we didn't really understand how it worked or why it worked. And sometimes it seemed to not work, and other times it did work. And why was that? What was different? So I started doing I would say, just research there, where I would go and change a variable and then see how that variable affected, the outcome. How did that variable affect my ability to remote view? And then I'd change, hold everything else constant, and I'd change another variable. And, that's the way science is done. You try to isolate all the variables, and then you change one to see how that one variable affects the outcome. So I did that for about 35 years. And after a decade or so, I parted company with Bob Monroe in the lab, just because my career took me away from that area, that part of the world. And also by then, people found out that we had this course that could help people get out of body, could help them explore consciousness. And pretty soon, instead of doing research, we were doing training. We had more people than we could deal with. They were always coming, oh, teach me, show me how. So Bob started putting together courses. And that's where the whole concept for the Monroe Institute came from. Was Bob suddenly said, gee, we got a lot of people want to understand. So he set up a teaching place called the Monroe Institute. But by that time, Dennis and I both kind of had gone. We were interested in the research, not in being trainers. So in any case, so the next 35 years afterwards, which takes me up to about 2002, I'm doing research, changing variables, seeing what works, what doesn't, trying to come up with some kind of an understanding of what was going on and how does it work. So I had all of these facts that I had learned about consciousness, things from my research, and I had all these facts about the objective world I knew as a physicist, and I was looking for an explanation that would explain all of it, one overarching explanation that would explain it all. And I found that. I found what was the paradigm shift necessary to explain all those things. So I made a model, started refining the model, started making it make more sense. And places where it didn't seem to work so well, I thought about it and see if I could change it or enlarge it or whatever. So I just started working with that. And in 2002, I published, I think it was 2002, maybe early 2003. No, I'm not sure. I published the My Big Toe trilogy, which was basically a model of consciousness. and an understanding of consciousness and what consciousness was and what it was to us and how did we relate to it and what was its significance. So that was a logical model of consciousness. And then about 2 or 3 years later, I got a couple of aha moments where I was able to also derive quantum physics and relativity. And I wasn't able to do that at first. I knew that I should be able to, but I wasn't quite able to do it until a couple of years after I published the books. Because one of my facts of consciousness that I knew was that consciousness was fundamental and the physical world was not. Physical world was a derivative of consciousness. And I knew that as a fact because my research said that I could do things in consciousness that would modify things in the physical world. But it didn't work the other way around. I couldn't do things in a physical world that would modify consciousness. So that means that the arrow of causality was from consciousness to the physical world. You know, that's the way it flowed. So I knew that consciousness was fundamental, but I wasn't yet able to derive physics, quantum physics from it. But I did get that insight a couple of years after publishing. And then I thought, well, what about the other big mysteries in science? Because you see, quantum physics is a big mystery of why should particles be best described as probability distributions? Big mystery. You know, why is it that if a person knows which way the particle goes through that double slit, if you know which way, then you get one answer. And then if people don't know, then you get a different answer. And why is that? You know, big mystery in quantum physics. That's what makes quantum physics weird science, weird physics. So once I understood that, I thought, wow, what about relativity? And the big mystery there is, why is the speed of light a constant? Mm-hmm. Because if you know, that's assumed. That's what we measure, but we don't know why it should be that, because nothing else in our reality is that way. Everything else, the velocities are additive. In other words, if you're in a car going 10 miles an hour, you stick your hand out the window and throw a ball at another 10 miles an hour in the direction that your car's going, relative to the ground, that ball is moving 20 miles an hour. You see, 10 miles an hour from the car, 10 miles an hour from your throw. They add. Mm-hmm. You take a flashlight and you move it, 80% the speed of light, and you turn the flashlight on, the light doesn't come out at more than the speed of light. It always comes out at just the speed of light. It doesn't matter what the source of the light is.
Amazing.
You see, and that was a big mystery. And really, relativity was built on that mystery. That was the thing. And first he did special relativity, which came up with a lot of strange things like time dilation and length contraction and that sort of thing that were, of course, immediately thought was crazy by the rest of the physicists. Well, that couldn't possibly happen. That's ridiculous, And of course, it all proved out to be absolutely true. When they did the experiments, yes, indeed, the faster you go, the slower time goes by. And the faster you go, the more massive you become. And the faster you go, the shorter you are, the shorter your length in the direction of your motion. All of those things actually happen. And that make relativity a weird science as well. Mm-hmm. And then general relativity was an extension of that added gravity to it. It was a new model, a new gravitational model, is what made general relativity. But still, the thing that was the big mystery was, why is the speed of light a constant? Sure. And then I got that too. My model said exactly why it had to be a constant. And then I said, well, what about the other things that are unknown in physics? And there's a whole bunch of things that are not really understood in physics, where the physicists say, well, we know this happens. We know reality is like this, but we don't have any idea why. Yeah. And, some of them are pretty obvious, like Big Bang theory. Well, we start with a ball of plasma, and that plasma is under high pressure, high temperature, and then at time equals 0, we let it expand, and this universe evolves, right? That's the Big Bang theory. But what you don't know is, where did that ball of plasma come from? It didn't come out of this universe. It's obviously prior to this universe, not a part of it. It had to exist before this universe could begin evolving. So I thought about that, and my model explained it perfectly. And we have things in physics called I think it's called the anthropic principle, where there are 4 or 5 fundamental constants. They call them cosmic constants that are all tuned to each other. That if any one of these constants changed in, say, the 8th decimal place, we wouldn't be here.
Right.
The whole universe would become unstable.
Right.
It would have collapsed in on itself. It would have blown up and scattered and never done what it is. So our universe is only stable enough to allow us to evolve because these 5 constants are tuned to each other down to the 8th or 9th decimal place. You see, and people looked at that and they said, well, that's really weird. If all this just happened kind of randomly, came together, how do you explain 5 constants just randomly coming together right down to, 8 decimal places? That sounds like it was planned or created. And that made a big stir, about 2 or 3 decades ago, when they came up with that. And so that was another thing that my model explained just precisely, exactly why that happened and how it came out that way. And then there was a thing called the Zeno paradox, which was if an atom decays in, let's say, a minute, and let's say it starts in state A and it decays to state B, and the half-life of that, say, is a minute. So it decays, you expect in a minute that a decay will come out. But if you measure what state it's in every 10 seconds, it'll stay in state A. So you say, well, I measured it, it's in state A. Measure it again, it's in state A. Every 10 seconds I measure it. I could do that for a year and it would never go to state B. It always stays in state A. And that was a paradox. Oh, why is that? Why doesn't it just go to B? And my model explained that. So I looked at all these paradoxes and even fundamental things. In physics, there's a few basic things that all the rest of physics is just how these things interrelate with each other. Those things are space, time, gravity, charge, spin, those kind of things. Just very basic things, mass, and everything else is about how those things interrelate. And all of those things have no cause. If you ask a physicist, where does space come from? Where does time come from? Where does charge come from? They won't have any answer. So here in a science based on materialism, where everything must have a material cause, after all, that's that thing about it has to be measurable. It has to be something you can interact with, right? That's what makes it real. Well, that means that everything has to have a material cause. Things that don't have material causes either don't exist or aren't important, but yet everything at the basic of physics does not have a material cause. It's causeless. So that tells you there's something we don't understand, right? That materialism is not, it's like classical mechanics. Well, it works pretty good in this area most of the time, but it only works here. It's not a general understanding. It's more specific to that. It's a subset of something bigger. So we know from quantum physics, from the fact that we don't understand where all the basic things in physics come from, that there's something else behind our objective reality that will answer these questions. That will tell us where did that ball of plasma come from and why all those constants got tuned. How did they get tuned like that? What was the process of tuning?
Sure.
So in any case, there's lots of mysteries like that, lots of paradoxes in science. And this model of mine answered all of them logically. And this model of mine has only 2 assumptions, and that's that consciousness exists and that evolution exists. In other words, a system that's self-changing will change itself according to the constraints of its environment. That's all. So those are the only 2 assumptions. And from that, I can derive everything else. So it's a science. It's a science very much like our biological evolution. Our biological evolution is a science, obviously. Like we notice that dolphins have finger bones in their fins. If you X-ray a dolphin's fin, well, this is what you see. you see a bunch of finger bones with little joints in them and so on, which are obviously useless in a fin, but it tells us that that animal evolved, to grow that fin after it had evolved, fingers. Yeah. So anyway, my model is also an evolutionary model. How did consciousness evolve in order to produce everything that we have now? And why? Why did it have to do this? So it's not like, well, I just imagined that it did this and this, but logic had to demand every step had to be logically necessary, not just something I thought sounded good, but it had to be logically necessary for the total logical argument. So anyway, that's kind of where I am and what I do. I've come up with this model. It is a better physics, and it also helps us understand who we are and what we're doing. And interestingly enough, one of the results is that it answers the big questions like, why are we here? What's the point?
Yeah.
Is there a source?
Right.
What is our source?
Right.
What is our source? And how did our source get to be our source? And all of those things are also understood. And it turns out, and all of this is logical, I'm not making this up because it sounds good, but it turns out that what we're here for is to grow up, is to become cooperative and caring and helpful. And we're here in order to become love. And all of that is in terms of entropy. We're here to reduce entropy. And now, so I've jumped to the end, given a little bit about the beginning.
Sure.
And there's an awful lot of logic and science in the middle that I haven't gotten to yet. But that's just kind of give your listeners kind of a viewpoint of where we're going. Now, I expect in the next 2 or 3, 4 decades, that this theory of mine will probably become mainstream because it is just a better physics. Sure. And paradigm shifts often are very difficult. They take a long time. Like the paradigm shift that the world was flat was round and not flat. That paradigm shift took about 200 years before it finally solidified. The Greeks understood without a doubt that the world was round. It was not flat. They had several things that they had done, with the curvature, that you'd see how the moon would light up during its phases and there'd be curves to it, that a ship would sail out and not just the whole thing just kind of disappear, but first you'd see the whole ship and then just the top part. And then the last thing you'd see was the flag at the top of the mast, and it like the ship was sinking into the water. And why was that? Well, it's because it was going over a curve. So there was evidence, and we have written documents that Greeks understood that the world was not flat, that it was round. They didn't understand exactly why, but they knew it was that way. But 200 years later, we were still having that argument. So paradigm shifts, big paradigm shifts, take a long time. The paradigm shift that the Earth was not the center of the universe.
Sure.
Not the center of our solar system, much less the center of the universe. That took a long time. There was facts that some astronomers had said that that's not the case. That doesn't make sense. And of course, that took hundreds of years before that. So paradigm shifts that are big shifts,
I get your point,
take a long time before people get it, because it's so different than the way people are used to thinking. It changes the way you see reality, the way you see yourself. And that isn't an easy thing to come by.
Right.
People will listen. Relativity was like that. For probably 30 or 40 years, everybody thought that was a crazy idea until we actually had the ability to do the experiments. And then science surprised itself that, those things are all true. Things actually do those weird things.
Right.
So in any case, this is a big paradigm shift. And what this shift is to understand that consciousness is fundamental. Right. Consciousness is the fundamental real thing.
Right.
And that everything else is a product of consciousness.
Okay.
Now, the way that works is that consciousness, I define consciousness as an information system. Consciousness is really about information. What are you conscious of? Oh, I'm conscious of this. And what is this? This is information. Yes.
Mr. Campbell, the thing is, I have all these questions, and if it's okay with you, I would like to go into them as I have prepared it, because there's some questions based, because I've done my research. I have also gone through some of your videos, so I have a sense of what you mean, but there is something deeper, deeper or something more I'd like to get into. So like in...
if you could give me maybe 2 minutes so I can wrap up where I was, and then we'll stop, and then I'll stop. Okay, I just wanted to wrap up and say consciousness is fundamental. Consciousness is an information system. Consciousness is defined as awareness with a choice. In order to have information, you need choice. So consciousness, the simplest thing of consciousness is something that's aware. It could be in a state A or state B. It could be in one of those two states. That's like your smallest unit of consciousness. You take consciousness down from something complex to something small. It's something that's aware that it exists in state A or state B. So it has a choice. It's just awareness with a choice. And from that, I evolve everything else. And I'll just quit there and let you jump into where it is you'd like to go next.
Okay, great. Thank you for that wonderful story and the summary of your own journey that you've given. So now the question that I'd asked you was that your approach to physics. So I was also trying to look for, as far as I could understand, how you approached physics. So something that you said in the beginning was you were kind of born with this drive to take things apart and then see what they're made of. And I don't know if you also went on through the process of putting them back together, but there was something that drove you. And then another thing I think that I took notice of is that when you had that experience of seeing the errors that you haven't made, but the machine made. So somebody can't even come and say that, oh, the errors were made by you. So maybe you unconsciously registered it and they showed up. This was made by the machine, right? Which you did not know. So the machine made it. And when the errors made by something other than you, you could still see it. And the results of it kind of got your attention. They did not scare you, for the lack of a better word, right?
No.
So this is the approach that I'm looking at. So now what I also want to know from you is, and if we can keep it it's succinct as we can, if this is the way you approach taking things apart, what could it be? What could be inside? What could be inside? And to not be really taken aback by the result, but say, okay, let's see what it means. It's not something that I'm used to. It's something different, but let's see what it means. So not holding back this pull that you feel. That kind of an approach, if this is all there is to it, in what way would you say your approach is different from, let's say, contemporary or rather mainstream physicists in terms of how they approach physics?
Okay, the main difference is that mainstream physics is captured by a belief in materialism. They believe in materialism, and they had that belief once Newton explained some of the basic, ways that the world worked. And I think the metaphor that you've probably heard is Newton's clockwork universe. This clockwork universe is an idea that this universe is a big machine, and physics then came to the conclusion that this reality is a material machine. And they believe that if you knew the position and if you knew the state of all the particles in the machine right now, if we knew every particle, where it was, how fast it was going, and so on, then we could predict everything that would happen in the world from then on, because it's just a machine and the next state is just an extrapolation of the last state. So you could extrapolate out, and even 1,000 years from now, you could predict everything that's going to happen. So if you are a materialist, you must also be a determinist, because that makes it, a machine is a deterministic thing. If you do this, that will happen. It's all physical causality all the way out. So it's a deterministic machine. And that is a belief, and it's also not true. So typical physicists are trapped with this belief. And belief in science isn't any different than belief in theology. Once you have a belief or any other kind of belief, then that belief limits what you can think, because things that are contradictory to that belief are immediately thrown away as trash, things that didn't really happen, appearances, hallucinations, that sort of thing. So that's why the things that are paranormal are thrown out as not science. Couldn't possibly be. They couldn't happen because they don't follow materialism. There's no material cause for that sort of thing. Therefore, they don't exist. So science, instead of being what science should be, which is, oh, these people say that these paranormal things happen, then let's study that and see how that works. Science looks at it and says, that's impossible, doesn't exist, it's all bogus, people are making it up, or they just are having hallucinations. So that's at the core of mainstream physics, is a belief in materialism and a belief in determinism. And that limits where they can go. So they are stuck with this belief, and the belief is wrong. Okay. It is just not the case. So that's, it's like the same thing would happen back when they were trying to science was trying to come up with the idea that the earth was not at the center of the universe. Well, in that time, the high priests were religious priests. And they said, no, that's not part of the way we see the world. We see the world as that God created humans and the earth and everything else, and we're the center of all things. And that was their theology. And because these other ideas were contrary to their theology, then they were wrong. And those people often were punished for those ideas. So it's the same thing. That's the way belief works. I call belief a belief blindness.
Sure.
Belief blinds you to things that are contrary to what you believe, and you just can't see those things that are contrary to it. So science is stuck in a paradigm of materialism that just doesn't work. Now,
okay.
Quantum physics says it's wrong, but they stick to it anyway because they don't have any other better ideas of how it might work. So that's the main difference between me and other physicists, is that I was always open. And I guess it was because I took that transcendental meditation course and found I could debug that software that, I didn't get frightened or bothered by that. It's like, oh, it works. Because I didn't just do it once. I did it many times. Mm-hmm. I experimented with it and it just, what you have experience. You either deny your experience or, maintain your beliefs. And I was not one to deny my experience. My experience was real. So I started looking for solutions and answers why, and wanted to study it.
Okay. So like you said, it limits their thinking. This addiction to the belief and this inability to, or probably if it's belief, and also maybe the lack of not knowing what to do if you give up on the belief, whatever the reasons might be, then you said it limits their thinking. So what is it that a faith in the materialistic view of the world, a mechanistic view of the world, that kind of a way of looking at the world, what are the physicists then leaving at the door? Are they leaving intuition? Are they leaving creativity? Because we've spoken to a couple of physicists and philosophers of physics who value intuition, who value imagination, who look for simplicity, who value beauty. So what exactly are they leaving at the door that, for whatever reason, in your estimation, is keeping them from making this breakthrough of reconciliation between things that seem to have this logical conflict, say?
Oh, well, what the problem is the same problem that I mentioned with all paradigms. When you have a paradigm shift that is major, big paradigm shift, and I should say that through history, all the paradigm shifts we've gone through, even including things like the Industrial Revolution and from agriculture to industry, and now we're into the information age. That's another paradigm shift. Whenever each paradigm shift is a little bigger than the next, they keep growing because they keep expanding and taking in more and more of our reality. So this paradigm shift is really, really big, and it requires them to see the world in a totally different viewpoint. And that's just hard. So yes, physicists you know, physicists will say, well, yeah, I understand that the subjective part of life is important, but it's just science doesn't go there. Science doesn't have anything to say about that. That's just in the mind, and mind is not part of, I can't calculate mind. It's outside. So they recognize that it's there. They can even see that it's important. They can appreciate that all those numbers had to be, all within to the 8 decimal places, all had to be tuned to each other. And it's just a mystery. It's just a paradox, and we don't understand. But yes, that's important. Sure, the imagination's important. Sure, our intuitive side is important, and my creative side. They understand that, but they don't know how to put that into a context that is science, that is scientific, that is logical. In their mind, it's nice and it's important, but it's not logical and it's not science in the sense that they think of science. They think of science as just logical process, which it is. That's what science is. My science of this big toe is just logical process. It's just like all the rest of the science, but their logical process gets stuck in materialism, and they can't get outside of that. So in their mind, all logical process has to come from this root of materialism and determinism, the great clockwork universe. Right. And they believe that so thoroughly that these other things are just remarkable, wonderful things that are out there, but they're, we don't have a way to turn them into science. We don't have a way to turn them into logic. And that's where they're stuck. And it was the same, with the guys that created quantum physics, Albert Einstein wasn't the key one, but there was, Bohr and Planck and Schrodinger and a whole bunch of scientists that worked this out. And they knew at that time that there was this experiment, the double slit experiment. If you read those people from that time, they'll be making quotes like, wow, this is a tremendous breakthrough. Reality isn't at all like we thought. Materialism isn't, they have all these great ideas, but they couldn't take the next step. It's like, well, okay, now, so what is it? And it's like, well, we don't know. All we know is that materialism doesn't work, and it's going to be something really wonderful and big, but 100 years later, and we haven't moved past that. We're still, but we don't have even the slightest concept. That's a quote from Einstein. He said, it has something to do with consciousness, but I don't have the slightest idea how to put that into a scientific theory. So that's the problem. And it wasn't until the 70s and 80s and 90s that the concepts required were available. They weren't available back in the 1920s. The basic concept is that this reality is information-based, which means it's computable, which means it's a virtual reality. And the concept of a virtual reality didn't exist in the 1920s. So they couldn't go there because they didn't have the fundamental concepts to go there. Now we do. But this virtual reality is not virtual reality that's programmed like we think of it. Consciousness is the computer. Consciousness is an information system. So it all ties together with that. And it's such a big step, this paradigm shift, that physicists have a hard time with it in general of getting over that step because it's so much undermines everything they have believed since they, took their first physics course. That's the problem, but it's changing. Everything changes. Max Planck, who was right in the middle of it. This is a quote from him: "Physics changes one funeral at a time." Basically, what he was saying is, you just have to wait till the old, runs aground, and the new tends to slowly replace it. And that takes a long time.
Yes.
So that's where we are. We're at the beginnings of that, because right now, probably 20, 30, 35% of the physicists, particularly those that are in high energy physics or particle physics or quantum physics, they will say, yes, we agree that reality is information based. A lot of physicists agree with that. And they know that is not according to materialism. but they will say it anyway. But then if you say, well, what does that mean? What are the logical implications of that? Where does that come from? What do you mean it's information based? And they'll say, I have no idea. I don't know what to do with it. Just like the quantum physicists were, back at that time. They don't have the idea because it's too big a stretch that this is a virtual reality, and the server, the computer, is consciousness. Conscious information system, and consciousness is fundamental. This reality is virtual. But you have to understand, well, why would consciousness make this virtual reality, and what's the point, and how it is that we interface with it, and what does consciousness have to do with us? And all of that logically comes out of the model, but I don't want to go there now. I want you to ask me your next question.
Yeah, but we will go there for sure, because that's going to be a very interesting bit to understand.
Yeah, so, there is one thing I should maybe say that I didn't comment on that I think you'd find interesting.
Sure.
I told you that as a young person, I took things apart and I did put them back together again because that was necessary to understand how they worked. And I kept taking them apart and putting them together till I understood how they worked. And I asked a lot of questions and drove my parents crazy with all the questions I asked them. But besides that, I came into the world very right-brained, very intuitive, and not logical process at all. I came into the world being just the opposite of that. When I was very young, you could ask my sister now, we'd go on trips that would be long trips. You know how children are on long trips in a car, they're there 10 minutes and are we there yet? They get easily bored. And what I would do is I would just start chanting a little phrase and zone out. And then 4, 5, 6, 7 hours later, when we got there, I'd kind of wake up and it's like just 10 minutes had gone by. It all just disappeared. So my sister was very upset with me because she wanted to play. Yeah. She wanted to do other things, play little games. That was before there were Game Boys and things. That's a long, long time in the age of dinosaurs when, we didn't have all those little gadgets to entertain ourselves with, or I probably would have been busy with a gadget. But in any case, so I was doing those kinds of things. I had very holistic. I knew when I was 5, 6 years old that I could change things with my mind. I would be in the car and I would try to use my mind to make all the lights change green when my dad was driving the car, so that we could go all the way across town and not get in a red light. And I was practicing those things. So I was that way, which was very extremely right-brained, holistic, big picture stuff. And then somewhere around 6, 7, 8, I got into details and learning, taking things apart and putting them together. And I had all of that. And I had this notion that I needed to understand those things. I needed to exercise my left brain. I needed to learn how to do logical process. That was important for me to learn. So I struggled with it and worked at it, which is, I think, why I took things apart and put them together, because I was driven to logical process, because I was excessively non-logical process up until that point. So that's just a little different slant that's kind of unusual.
No, it's interesting because there was a thing I wanted to ask you, a question that was not here, but so when you take things apart and you put them back together, I'm sure you've heard of this concept called the ship of Theseus.
The
right?
what?
The ship of Theseus.
Oh, okay.
So basically it is, if you've taken something apart, when you put it back together, it'll never be the same. Something like that. You see, yeah. So would you say now, when you did it when you were a kid, and I know a lot of other kids who have this tendency to take things apart. We have some friends who did this in their childhood as well. So now, if you bring it back to now, right? If you still continue to do that, you could probably do that with a concept, maybe not with a little toy, but you could pull apart a concept. And then when you put it back together, I don't know what that means in terms of a concept. Well, how do you put a concept back together? What does that mean? You pull it apart, how do you put it back together? But how does this appeal to you? I guess the question would be on an intuitive level, how does this appeal to you? This whole idea that it can never go back to be what it was. So if you open it up the next time, it's going to be something different altogether.
Yeah. Well, in the world of concepts, that should be true. that it won't be the same. Now, in the world of things, like I remember I got kind of stuck on flashlights for a while when I was little. I'd take flashlights apart, and the bulbs and the batteries and the little switch
Right.
and put those back together and then turn on the light. And sure enough, it would work again. And, just little simple things like that. Well, they always were the same in the sense as you put it back together and it works. But that's a simple thing. Ideas are complex. And if you take ideas and concepts apart, you should learn something. I mean, that's the whole point of taking them apart, is that you don't just believe it or just turn a crank on it, but you really understand it in a deep way. And when you understand it in a deep way, then it's different. You've learned. So that's what's different. You're not the same anymore. You've grown. You've learned something about this and how it relates to other things. It's not just things singular in themselves, but how does this thing relate to that thing and that thing to the other thing? And how does it all relate to this world we're in and everything that's here and all of our ideas? And you take everything and make it relate to everything else. And when you do that, you learn, you grow, you change yourself, and now you see connections that you didn't see before. So now when you look at that thing, it's not the same thing because you've figured out all of its connections and all of its kind of, I don't know, say meaning, but its significance, its part that it plays in this world and in this reality, in your life and in the life of the others, and how what's the importance of that? What does it does? How does it enable other things to do what they do because of what it does? You see, you have this bigger picture of the connectedness of things, and that was partly what was driving me taking things apart and putting them together, was to see what was connected to what and what did what to what. And if you do that with ideas, then no, you shouldn't be the same. If you did, you wouldn't have learned anything.
Right.
So only if you don't learn anything would it always be the same. If you do learn, then it'll never be the same because you're not the same.
Yeah, I understand. Now, I have a few questions for the book, the trilogy that you've written. So you wrote and published it in sometime in 2002, 2003, sometime around then.
Yeah.
So it's been what? It's been almost 2 decades since it was first published.
Yeah.
Since then, have you ever revisited certain ideas or certain, let's say for the lack of a better word, certain claims that you've made in the book and said, okay, I need to correct this here, or something has changed in my own understanding of things?
Yeah. Yes, I did. And that was what I'd said before. After it was published, I got the aha moments about the details. I had the very roots of it, but I didn't have the details of how to derive quantum physics and relativity. I just hadn't thought of it. And then once it came, it was, obvious. I should have gotten that, but I just didn't. So yes, that changed. And then I went back when that printing ran out and I had to print them again. I made some changes. Not a lot of changes, but I just added a little more depth to what I had kind of hinted at. Now I could be a little more specific, and I added a little more depth here and there, but I didn't add much in it because I didn't want those books to be difficult for people to read, any more difficult than they were already. They're not an easy read. They're very logical, and a lot of people don't do logic very well and find them hard to read. But so I didn't want to do physics in a book that was meant for everybody.
Right.
But I talked about most of the physics on my videos. They're on YouTube. I've got like thousands of hours of YouTube videos there, and that's where most of the science is. Matter of fact, on my YouTube videos, there's a playlist that just looks at the science of MBT. And it's got, I don't know, 5, 6 videos, not a lot, that just are specifically about the science of MBT. So most of it's there, not in the books, because I wanted the books to be for everyone. They were a theory of consciousness and understanding who we are and why we're here and how does consciousness work and how do we relate to each other. And that's really what I wanted my book to be about. And by the way, it's also consciousness is fundamental. Therefore, physics must come out of the consciousness somehow. So then I realized what the somehow was, and exactly how it came out of consciousness. So I went back and fixed a few things there. But I haven't reread my books recently, but after they'd been out for 5 or 6 years, I did reread them, and I didn't find anything that was wrong ever. All I did to it was add new things to it.
Add new things to it. Got it. So there's something very interesting you said. So you said that the book is written for people and it's difficult. So first I thought, oh, the book probably has a lot of equations and formulas, but you said no, that's not the reason.
No.
It's because it's a book of logic, and it is logic that most people fail to be logical about things. Now I want to understand from you, because and I think this can go beyond even the book. The fact that just understanding what logic is, what has your experience all these years of the kind of things you've been doing. Writing itself is an amazing process, right? And what can you tell us about what you have come to understand about what logic is as a physicist, as a writer, now as an educator? What is logic? What is logic? So in a way such that people can imbibe that and bring it to your book, bring it to generally, we can bring it to our lives generally in things that we do. That's anyway what your goal seems to be, that people should, there are very private, personal, inner things that we do, and there is a whole way to go about these things. So yeah, how can we become more logical? What are the steps to being logic? What is logic?
Okay, well, one of the things that we can do, people can do to become more logical, is first examine themselves and their own beliefs and their egos, their biases. Look at your biases. And that will maybe be helpful for some people, but most people won't see any biases. And they'll look and say, well, I don't have any biases. So that's not all that helpful. In reading my books, the thing that will help most is to just go slowly. It's not that people are incapable of following the logic. It's that in their habits, the way they interact with the world and with books, is everything is kind of quick and superficial. So they're used to reading a book, they read all the words, flip the page, read all the words, flip the page. They don't take the time to think, what does that mean? What is the significance of this? How does this affect my life? What is my experience relative to this experience I'm here? And so you think about it. And I had one young man read the book, and he said he read it once and thought he understood it. And then he read it again and thought it was a totally different book, that he had found all kinds of things in there that he hadn't seen before. And he read it again. I have one person that read it 7 times, and he says he still finds things in there that he can't imagine how he never saw them before. But it's because you have to slow down. And this one gentleman I was talking about, he said that he would read 10 pages a week. That's it, 10 pages a week. And if he did that, he felt like he understood it. But if he did it any faster than that, he wouldn't, because the ideas are big ideas. The ideas are ideas that take some thinking about, some feeling about, and people generally don't do that. Our society is so overloaded with things to read and information that we just want to kind of skim through it and get the idea and get to the end and say we've done it. So we read it and we don't really understand the words, but that doesn't slow us down. We just keep on chugging anyway. And what's this word mean? I don't know. I've never seen that word before. Oh, well, I sort of got what it means, and keep right on going. Instead, you have to read it with an idea of understanding. What is the understanding here? What does this mean to me? How does this affect my life? And how does it fit with my own personal, experiences? And take it just a little bit at a time. But the reason my book's hard to read is because it's so dense with these kinds of things to think about. Donna Vinny, Warner, who helps me, put up YouTubes and does my YouTube channel and so on. Her comment is when she first got in touch with me almost a decade and a half ago, she says there's more information in one of your paragraphs than there is in most books. She says most books I read, and she was reading all the books about philosophy and so on, they've got like one idea, one kind of different idea, and the whole book is about that idea.
Right.
And she says you read a whole book, and if you get 1 or 2 new ideas out of it, she says that makes it a good book. Says your book has 1 or 2 really different ideas to think about on every page. And if you don't slow down, you'll just skim right over them and you won't notice any of it. So that's why this guy could read the book 7 times and still find things that he never saw before, because each time he read it, he changed a little bit. He understood a little bit more, which made it easier for those other things then to make sense to him as he reads it. You know, some people will read my book and say, oh, it's very redundant. But it's not. It's because they're only looking at it at a very superficial level. And if you don't look deeper than that, then it seems redundant. You know, it seems like I'm saying similar things, but only if you boil it up to a very high level, you know, to a level
Sure.
of you know, very general. If you generalize it up to the top level where it's not really specific anymore, then it seems kind of redundant. So people have trouble with my book. Now, left brain people, techies, you know, doctors, lawyers, Indian chiefs, people who use logical process, that's what they do in life is logical process. They don't have much trouble with it. They still only get about 30% of the content when they read it the first time, but at least they can follow it and they read it. Those people who are right-brained and more intuitive, they find it painful. They find it really painful because they'll read a paragraph and they'll like, what was that about? They'll go back and read it again and it's still, what was that about? And they just have a hard time getting through it. And after a while, they just have to put it down and say, I just can't read this book. So those kind of people struggle with it some.
So like, what is it? Like, one I understand is you're being slow, which is a very good idea, right? To be slow. I think it also gives you the time to pay attention to something that is new, because you haven't seen something before. So if you're seeing it for the first time, might as well be slow and attentive to what it is saying. So from that, then is logic a natural outcome in being slow and in paying attention?
Yeah, well, logic is necessary because it has to make sense. You know, the book it starts at the very beginning. Actually, it's 3 books. Each book is broken into 2 halves. The first half of the first book is not challenging to anybody. That's just a little bit of biography about how it is I came to write the book. So everybody can read that, and it's really simple. And you can skim that and not miss anything. But then after that, after you get into the second half of the next book, then it starts to become more logical, more scientific. So from then on, it builds. What I say in this chapter, you need to understand before you can understand the next chapter. And you need to understand that before you can understand the next one. So it's like reading a math book. You just don't skim in a math book, or you don't go back to the middle of the book and say, well, I'll start here in the middle and see what's going on, you know. You can't understand it. So you have to start and get it as you go in order to take the next part. But it is abstract. I'm talking about very abstract ideas. And people who are very concrete in their thinking have some problem with the abstractions. And people who aren't used to thinking in logical process have a little trouble with the logical process. It just is annoying to them. See, when you're right-brained, you don't need logical process. When you're right-brained, you just skip to the answer. You know, you don't do all the steps in between. When you're intuitive, you intuit the answer.
I understand.
You don't have to go through all the steps. So they are very familiar with the answer, because they're intuitive, you know, right brain intuitive people. They don't have any trouble with where I'm going. And when we talk about it verbally, they're right there. They like it, they believe it, and it's all great. But if you ask one of them to explain it,
they're unable to explain it.
No, they can't explain it because they intuit it, you see. So they don't need all this logical process. And to them, going through all the logical process is like grinding, you know, stone against stone. It's just, you know, it's just so unnecessary, you know, because they get where it's going. They just have a hard time grinding through the logical process to get there, because that's not how they live their life. They live their life intuitively. So it's not that they can't understand it. They just don't like to have to go through all the logical process. And it's what, a lot of hard work. And
like so if they had to sum up the book, they'll sum it up in a page. They know the high points, things that they understood. This is what the book is about. Don't ask me to explain it.
Yeah, exactly. See, they kind of understand where it's going and how it's getting there, but they don't have any explanation. But you see, there's hundreds of books for people who are right-brained and intuitive about philosophy and about metaphysics and that sort of thing. But there's almost no other book that is logical process for the left-brain people. All the engineers and the scientists and the mathematicians and people, they'll start a book, like take a book like the Bhagavad Gita, right? There's a couple of guys on a chariot, talking about things, and you take a left-brain guy and he reads that, he gets in about 10 pages and says, I can't read this. This doesn't make any sense. What are these guys talking about? And that's because he wants logical process. But that's not written for logical process. That's written like poetry. You have to understand it. You have to know what the metaphors are and what they mean and apply them to your life and to, that sort of thing. So those left brain logical process guys need an on-ramp to this larger reality. So I basically wrote the books as an on-ramp for the left brain people so that they could get to this bigger picture of reality, but get there one logical step at a time, rather than have to intuit it or read poetry to get there, because they can't do that. Their mind won't take that path.
Right. So even if, say, you're right-brained or you're left-brained, so like you said earlier, at some point that even the certain kind of people who can get what I'm trying to say, get about 30% of it after, say, a first read and a little more after the second read. So now people who are reading it once, even the first time, who pick up a book which is big and then they go into it the second time, there is a force of will there, right? Some kind of a willingness or, the willpower to want to. So in consciousness, how does consciousness, as you have come to experience it and understand it and even explain it, how does it explain intuition and how does it explain will?
Okay, let's just start with intuition. We are not physical bodies. You are not a physical person. You are consciousness. I'm not a physical body, Tom Campbell. I'm consciousness. We are playing an avatar. Okay, now consciousness, so, who am I? I'm a piece of consciousness playing an avatar. I'm playing the avatar because this avatar gives me experience that I can't get other ways. Important, significant experiences that are otherwise impossible. So I'm skipping a whole lot of steps here, but the consciousness processes information in two separate channels. And these channels work well together, but they are mutually exclusive in how they process. And one of them is the intellectual channel. That's what its tool is, logic. The other one is the intuitive channel, and its tool is intuitive. Now the intellectual channel, you can explain. It's explainable. It's like I say, it uses logic. The intuitive channel is beyond logic. You don't get logic. With your intuition, you don't get a process. Your intuition doesn't say, A to B to C, therefore D. Your intuition just knows. You just get a knowing. You get information. Things become known to you or aware to you without any process whatsoever. And there's a lot of information available in consciousness. There are databases available in consciousness. There are databases that the rendering engine that renders this virtual reality needs to have in order to render the virtual reality. And all of that data is available for us. And a lot of other data too. Consciousness is also all netted. Every piece of consciousness is netted to every other piece of consciousness, just like we're all open to all the web pages that are in the world. Now, that doesn't mean we have to look at all of them, but we can we can connect to them. We can, click on that URL if we want to, and we can click on the little red X up on the top to get rid of it. So it's open and closing ports, if you will. And consciousness works very much like that. It's all on a net. So intuition is a person gathering information and understanding from the consciousness, from the world of consciousness. And it just comes as knowledge, as knowing. You get it not in sentences and logical process. You get it in big chunks. When you speak with another person telepathically, you don't usually get words and linear process. You just get understanding. You get paragraphs and chapters all in one chunk. And then you have to kind of unwind those later. But you get big pieces of content. So that's where your inspiration comes from. That's where the creativity comes from. It comes from the intuitive side. Creativity doesn't come in, well, first you should put your brush stroke over here, and then you should get some red paint and put it over there. That's not creativity. Creativity is just, whomp, oh, I got it. It's going to be like this. And then you go do it. You just get a download. Now, we spend all of our lives developing our intellectual side. We start learning alphabets. We start with mathematics, learning how to add and subtract, and we work on it all of our lives. We work on honing and improving our intellectual side. We know more things. We get larger vocabulary. We read books. We take courses. We go to school. We go to graduate schools. We're always working on this intellectual, logical side of ourselves. Our intuitive side, not so much. We don't do much at all to develop our intuitive side. So our logical side is well developed. Our intuitive side is like an infant. It's not developed at all. Imagine somebody, the old proverbial story about, the child was raised by wolves, never learned a language, never learned any intellectual stuff. And then what is that child going to do if you bring him to our society? They don't have a language. They don't have this, they're basically instincts. They act more like an animal than they act like a human being because they haven't developed that intellectual side, which is what makes us be the way we think of ourselves. Well, it's the same with the intuition. If you never develop the intuition, you're just lost there. It's something that sometimes happens, sometimes doesn't. It's kind of mysterious. It comes and goes. It's sometimes right, sometimes wrong. It's that, but you can develop that intuitive side. And if you develop it, you can make it just as accurate and just as reliable and even more informative than your intellectual side. In fact, when you develop it, it becomes the leader. For most people, their intellect is the leader. They go through their life with their intellect leading. Their life is lived out of their heads. When they meet a new situation, their intellect says, well, what should I do here? And what are the situations? And what do these things mean? And it does all the logic based on past experience and comes out with what it is they should do. Whereas the right brain, the intuitive side, just looks, immediately understands all the connotations, what's on the lines, what's between the lines, what was never put down on the lines. They just get all of that and they can work with it in that way. So eventually, as you grow up, you get more into balance. We're very unbalanced now. We have this left brain, this logical process is like huge, and our intuitive process is very immature and undeveloped, very out of balance. What we need to be is both. We need to have both the intuitive side developed and the intellectual side developed, and then they work marvelously together. Because the intellectual side, though it has a very precise tool called logic with which it works, it almost never has enough information for that logic to really be logical. It just has little bits and pieces of information, and that logical side's always guessing, particularly if it's something important, like who should I marry? Should I marry Sally or should I marry Sue? Well, my intellect gets that and wrestles with it, and all it'll do is confuse me. It doesn't have enough information, to actually do a logical assessment, right? You can't do a deductive assessment on it because you don't have a crystal ball that looks into the future that can see, what's likely to unfold and what's likely to happen. So it just guesses because it never has much information. Now, the intuitive side is just the opposite. You see, the intuitive side has all the information that you would want. It even has the probable future, probable future, not the future, but the probable future. And it has all the past, even just the probable past, not necessarily just the actual past. And it has all kinds of information, but its tool that it uses to bring that to the person is ratty. In other words, its tool requires a person's mind to be focused in a certain way. It requires the intellect to let go and be open. It requires a a state of consciousness to be open and ready and able to work with that. So most people don't have that, but they just drift into it for moments. They drift into that space where they're connected to their intuition for 3 seconds, and boom, they get a download, but then they're gone. They're not in that anymore. Now their intellect is now buzzing all about that and what they're doing and what's going on, and ideas are flying around in their head. And then maybe they get another few seconds of intuition. And some people hardly get any. That's why most of the people who do paranormal stuff, like out of body, it's all random. It happens occasionally, sometimes, but it's nothing that they really control. It's not something they just do. Whereas when you develop that side, you can shift your attention to another reality frame in a tenth of a second. You don't have to go through process. You don't have to go meditate. You don't have to do anything. It's just there. You can grab that process. You can access that information and that data. It just is a part of a larger reality you live in. Your intellectual side defines a certain amount of your reality. Your intuitive side defines a whole nother piece of your reality. And both of them together define kind of a whole reality that you live in and have so much broader choices, you see. And that's where we need to go. But we're mostly stuck over in that logical process side. Is another problem with scientists. They're stuck over there with their materialism and determinism, and they can't get out, and they think the intuition is either a hallucination or totally out of control and just something that happens. It's not something that happens. I mean, that's what if you were raised by wolves, you'd think language was somehow magical, and you would think that being able to read a newspaper was something that was magical. If you never develop it, then it seems like it's out of control.
Have you seen? Do you know of the show Seinfeld, 90s?
I've heard of it, but I've never seen it. I don't watch TV. I haven't watched TV really for probably 50 or 60 years.
Okay, so I don't know how to build the background here, but so there was a character named George in the sitcom. It was really, really wonderful TV show, and it's available on YouTube. All the episodes and all, you can watch some of them. So George was the kind of guy who had an idea of himself. So he was small, stocky, bald. That's something that's used about him, said about him throughout the show, right? And he kind of owns it also. It pulls him down also. So he always sees things in a certain way. So if, say, for example, he wants to speak with a woman, he starts thinking that he's like this. So if he approaches her and he doesn't even have a job, so she's going to reject him. But then he decides to do something called the Summer of George, where he says, I'm just going to do the opposite of everything that I've ever done. So what he starts to do is wherever he's afraid and he's about to say no, he'll say yes. And what happened is that episode resonated with people on such a level that the producers of the show, and they got so many letters from people that we kind of put this into practice. So I don't know, it's not to say that this is what intuition is, but maybe it can give us an insight into what how we take our decisions. So he had an image of himself built up in his mind, maybe to some extent reinforced by his friends who were very close to him, always surrounded by those ideas, people representing ideas, right? Characters representing certain ideas, and he kind of bought into that image. Sure. The fun guy, amazing, all of that, good looking and everything, but he bought into an idea of himself, and that defined his choices. So when he just pushed himself into an uncomfortable zone, he just became this guy who I think always wanted to be, right? Really cool, really, young, brash dude who's, up to anything. So of course he was back to being himself later on in the show, but you see what I'm trying to say?
Oh, absolutely. Yeah. In my theory, Disha, everyone lives in their own reality. Everyone creates their own reality. Now, they don't create it entirely. This is a multiplayer game. So things that I do affect you, things that you do will affect me. So it's a multiplayer game. But our reality, what we see as reality, is our own. And that's because in this virtual reality, we get a data stream that we interpret to be this, this physical universe, this physical reality. But that interpretation is based on us, our past history, our beliefs, our ego, our fears. The interpretation, how you interpret that data, comes from who you are and what you think, what your beliefs are. So this guy believed he was a short, little, bald, nothing of a guy. So that was what he believed because, that was his interpretation. But everyone lives in their own reality. And we can tell that, if there's an automobile accident on a street corner and there were 5 people standing on that street corner and they all saw it, you'll get 5 different accident reports. You won't get one accident report that's the same. You'll get all kinds of different things because each person will interpret that data based on their own experience base, based on who they are and their experiences. So we see things differently.
And even receive, right? Even receive the data. One is interpretation, even the reception of the data. He came from here, the guy who collided into him was on this bike or that bike, whatever.
Well,
right?
that's that's just all the data he receives in his in this reality. Because it's a multiplayer, you get what other people are thinking and all of that. That comes to, but then you interpret that. Mm-hmm. If somebody says, "Oh, he's just a short little guy that's not much," then you could get that and say, I don't accept that. I'm not like that at all. You see? Or you could say, yeah, that's me. You always have the choice. That's what you're here. As consciousness, you're here to make choices. And by those choices, you evolve. You evolve the quality of your consciousness. And that's the whole point of being here. And because evolution is really lowering entropy, you evolve to lower states of entropy. The system is evolving. And we are also evolving. We're pieces of that system. So this old thing that you hear in religions that we're all one, it's true. We are all just pieces of this larger consciousness system. We are all one. And because it's a social system, the way you lower entropy in a social system is by cooperation, by all the pieces cooperating and caring about each other. That lowers entropy in a social system. And the way the system evolves is by lowering its entropy. So we're evolving toward, kindness and caring and cooperation. That's the nature of consciousness. That's what we're doing. Now, de-evolving is when we are fearful. That's when we create entropy. Entropy is a measure of disorder, right? I probably didn't have to tell you that. You're a smart girl, well-read. You're probably aware of entropy. So it's a measure of disorder. So if you are fearful, then there's no trust. If there's no trust, then it's all about you, and you're very self-centered, and all of that is very high entropy. So that tells us about all the social stuff in our life and how we interact and where our problems come from and why we sometimes feel life is harsh and why we get angry. And all of that has to do with this balance between love and fear, and the fact that we are in a virtual reality game that's basically an entropy reduction trainer. And we are learning to make choices that lower our entropy and make us more civil, make us more kind, make us more cooperative. And that's the whole point of this game, to learn that and lower entropy, because as our entropy lowers, we, consciousness, evolve. So that's kind of the overriding ethic. So yes, everybody lives in their own personal reality. So if I say something to you, you could take that in a positive way or a negative way. It's up to you. And if you take it in a negative way, in your mind, I just said something negative. And if you take it in a positive way, in your mind, I just said something positive. So you turn that into your reality. You don't think, oh, I turned that. I interpreted that into something negative or something positive. You say, he said something positive, or he said something negative, you see. So you create your reality. You create the way you think people think about you. And we all judge others based on ourselves. So if somebody has some behavior, we think, well, if I was behaving like that, it would mean that I was upset. So they must be upset. Well, maybe it's not true. We're taking ourselves and using ourselves as a yardstick to measure somebody else's behavior. Right. They may be upset or they may not be upset. But in our reality, they're upset. Whether they really are or not, is a different question. So yes, we do create our own reality in many ways. We create our reality by how we think. One of the things in this system is that your mind modifies future probability, the probabilities that describe the future. Your thoughts modify future probability. That's why the placebo effect works. If a doctor tells you, oh, this pill is really going to help you, and everybody that takes this pill gets better, and now you have a positive attitude toward it, you will actually tend to get better because you'll start modifying probability toward getting better.
Right, but isn't it like that's such a good example here? But like there are always subtleties, as you obviously know. Like when the doctor gives it to me versus my elder brother gives it to me, when the doctor gives it to me versus my neighbor gives it to me. So there is something in that also, because I think faith that way develops on these little things we sometimes might not realize. It's the doctor, he's certified, he knows what he's talking about. You know, it's all said and done there, just take it, it's the doctor who said it, and then maybe the placebo works there. But what if you are someone who's very careful around people who are around doctors, and you get a sense and you say, no, this doctor didn't seem right, so if I take his medicine, will the placebo still work? So there are so many subtleties woven into this whole how things come about, right?
The placebo does not work then. Yes, it has to do with what you think, what you believe, how you come away from it. If you come away with a positive attitude, then you will help create more positive future. The probability of things happening in the future, it changes all the time. Depends on what all of us are doing. We're all interacting with each other. So if you have a negative, let's say you worry a lot, you get a little bump here or something, you go, oh no, that's probably a tumor, and you're worried about it and you obsess about it. Well, you raise the probability that it will be a malignant tumor just because you're worrying about it. If you're very positive about it, oh, that's nothing, it'll go away, whatever, then you raise the probability that it'll go away. So we create our own reality in multiple ways. One is by our interpretations of the information, and other is by our thoughts. If you're a very positive person, you tend to live in a positive place, and positive things happen. If you're a very negative person and everything's always awful and woe is me, all kinds of terrible things are happening to you all the time because that's how you interpret it. Whereas that same thing that you think is terrible, somebody who's positive has that same thing happen to them and they say, oh, this is going to be a challenge. I'm going to be challenged by this. I'm going to grow from this. Whereas the other person, oh, woe is me. Everything always happens to me. You see, so we create this reality. We create most of our own dysfunction, most of our own unhappiness, most of our anger is all self-created by us. And
you're speaking as a scientist, as a physicist. And
yes.
I read this book, Truth and Beauty, by a mathematician, an English mathematician, Mr. Ian Stewart, right? And in that he says, so science is, and not in only his book, in many other books, and after speaking to so many physicists and mathematicians, there is a world of math, there is a world of physics where there is rigor, where there is discipline. As much as we say that it's not just a mechanistic world, but when you are in it, there is, like we were talking about logic comes out of logic. So you are in a place where you are more certain than you're not. More often than not, this is why it doesn't work. So you don't fret too much over it, so, and this is why it works. So you get it. But then he calls what the messy real world, where the interactions are not so deterministic, the outcomes are not so deterministic, right? So as a scientist now, even though you've used you have reconciled in your book the objective and subjective reality, the chances of in a human being, in a life of a human being, things being less determined if you just let go and then still finding your feet, do you understand what I'm trying to get at? Like how does a scientist would talk about the life of a human being with all these emotions and thoughts which don't seem to have an empirical side to them, so to speak? We have a sense of priority, okay, but
well, they do have an empirical side. That's my point. My model is not only a science of the objective, but it's a logical science of the subjective as well. Right. So they do all have an explanation. Now that whether or not you can do anything about it, well, you have to grow up. You have to have some ability to change yourself or to change how you interpret things or whatever. So then you have to grow. So what you can do about it, but if you want to understand exactly why you're upset or exactly why you're angry, then this will tell you very logically why it's like that. So it takes all that kind of mystery out. But now learning it, say, okay, the reason I get angry is because of this. But now changing yourself so that you don't get angry anymore, now that's harder because you have to modify who you are, how you interpret the data. You have to modify, what you believe. You have to change your ego, get rid of your fear. So those things now are difficult to do. So just because you intellectually understand what's going on doesn't mean that it's easy to change it. But at least you can understand it and know exactly why you feel that way. Why is it that this world upsets me? And I get so angry when I watch the news and I shake my fist at people and say, you people are just so stupid. If you just, be nice to each other and stop fighting and stop doing this, we could all live in a much better place. And you get upset and angry. Well, the reason that you're angry is because things aren't the way you want them. And getting angry because things aren't the way you want them has to do with being self-centered. You get upset because things aren't the way you want them to be. They're not the right way. And the right way is defined as the way you want them to be. Everybody defines the right way as the way you want them to be. Yeah, everybody defines it that way, you see. So anyway, this does turn that intuitive side and that subjective side into a logical science. But it doesn't mean it makes it easy for you to change who you are, how you see things, or how you interpret. You still have got those fears, you've got those beliefs, you've got those attitudes, and until you change those, well, all the knowledge in the world about why you're like that won't help.
Right.
You have to change. So you see, so it does though give you clarity about why you're like that and what is the right way, how you should be and why. In other words, okay, I get angry, but you can understand, well, if it wasn't for my ego and my beliefs, I could see that this should matter and that should be this way and that, and you can see where you need to go. But just going there is not always easy. So it's difficult.
Right, exactly. Yeah, totally. Change is difficult, walking through fire and everything. And like earlier you had said that what we call the objective reality as scientists see it is a subset of something larger. Now what I want to ask from you is, from your book and everything that you've written, and let's say everything that you've experienced in life, just this understanding, and not a very fly-by-night understanding, but a very, you hold on to, you really sink your teeth into this phrase that this is a subset of something bigger, and coming into an understanding of whatever it may lead to, whatever understanding it may lead to, is that something that brings someone peace, like in the sense that they're okay with being where they are, and then it doesn't make them nihilistic or anything, but it just brings them a sense of calm, and then they can carry on with their life in a better way. Is that a nice thing you would like people to take away from your book?
Well, that is one thing that would be helpful. But first, before they can become calm, they have to let go of some fear. Fear is what keeps us from being calm. So yes, seeing that there is a big picture, seeing that there is and understanding what is source. I've had any number of people who describe themselves as religious. I'm a Christian, I'm very religious. I expected those people to be upset with my book because my book doesn't verify any of that. My book is all logical. But I've had any number of very religious people really, really like my books. And that's because they didn't get stuck in the dogma, but rather could see the big ideas. And in their mind and their explanation, my book, one of the things it explains very logically is what they think of as God, source. What is source? Where does it come from? What is it? And how do we relate to it and it to us? And they find all those answers in there that are not belief-based, but logic, part of the logic of the model. So yes, some people, if they're not so fearful and they see that there is a bigger picture, because just seeing that there is a bigger picture is very comforting to some, but it's discomforting to others. It just depends on where you are. If you tend to be secure, and if you tend to have your own power, to have personal power. And by personal power, I don't mean you reach out and tell other people what to do. I mean that you're good with yourself. You're authentic. You accept yourself, you're okay, and you're out in the world and you're making your way in the world. If you have that sense, then that means you're not really insecure. You're not feeling inadequate. You feel okay. Doesn't mean you feel perfect. It just means you feel okay. Well, if you're that way, then yes, you see a bigger picture. You see that there is purpose, that there is explanation of why we're like this. How come we're all so angry with each other? How come the corporations are trying to, rip us off? How come the politicians won't tell us the truth? And you get all these things, and suddenly you get, oh, I get it. I see why it's like that. I understand why it's exactly like that. This world reflects us perfectly. It's our quality of consciousness. It's just on display here in this world. And you also, instead of saying, yes, but I'm grown up and those other people are the problem, you see that everybody's here in the same boat. We're all struggling to do the best we can with what we've got. And everybody's on a path toward this evolution of their consciousness. So we're all kind of in the same boat, doing the best we can with what we got. And the more capable we are, the more we understand, the more helpful we can be to other people. So when you do that, then the big picture is very comforting. But if you have a lot of fear, then the big picture is a problem, because, oh, there's this big picture. There's this source. Oh, it must be an evil source, or otherwise we wouldn't have all this dysfunction, all these terrible things in the world. Why doesn't the source come down and straighten it out? Well, it doesn't work that way. The source is not your mother and your father, and you're not a little child. So some people find comfort in that big picture. Other people just feed their fear into that bigger picture and make it a big scary picture and a big, unhappy picture, rather than something that's valuable and helps them understand. So it depends on the individual. But for someone like yourself, yes, seeing the bigger picture, seeing how things are explained, seeing a good explanation for theology, and realizing that, if you look at all the theologies around the planet, you can see they have some basic similarities to them for the most part. And that those are the things that are real. And where does that real stuff come from? What is that? When the Buddha 2,400 years ago said that this reality is an illusion, what does that mean? Well, now it becomes science. Oh, it's an illusion. It's a virtual reality. That's why he called it an illusion. You see, and all those things that you learned as poetry and as big ideas that felt right and you resonated with them, now they all make logical sense. So now they become science, and they're part of a logical thing that starts very simple and then builds logic up through the whole thing. So for that is very satisfying for a lot of people who are seekers and open-minded. In my books, I have a couple of things I keep iterating, and one is you must be skeptical of everything. Always be skeptical. And the person you need to be most skeptical of is yourself. And the other thing, and I say you also have to be open-minded. Skeptical, but open-minded. And if you are those two things, you'll eventually get to where you want to go. The other thing I say is that if it's not your experience, it's not your truth. And if it's not your truth, don't jump to beliefs, other people's truths. If it's not your experience, it's not your truth. Everything doesn't have to be, I believe it or I don't believe it. There's this broad range between those that says, I'm thinking about it. I'm collecting data on that subject. I think it's true, maybe 50% or maybe 30% or 10%.
Right.
That's fine.
That's why people say, no, right, learn from other people's mistakes. It's not an experience you've had yet, but if you have that discretion, and maybe if you can know what to filter out, but it comes from your own experience, how much serious you've been about what you've experienced. And
even if it's other people, if you look at other people's experience, you still have to do the learning. You have to do your own learning. You have to look at that, assess it, see what it means to you, accept the parts that you think are new and valid, and then go on.
Yeah.
In other words, the learning is all yours. They are just a trigger for you to learn something by seeing the mistake that somebody else made. But we mostly don't learn a lot, like, because people lecture to us, we don't learn that way very well. It's a terrible way to teach anybody anything, is to lecture to them. We learn by doing, by living, by connecting. We learn with our relationships with other people. That's where most of the learning actually takes place.
That's fun. Learning is fun. My conversation with Mr. Campbell was a lot about hope and the power of the human will. It showed me the ability of science to go beyond itself and in our potential to find a purpose in existence and to find meaning in that purpose. It will be wonderful to know your thoughts on the interview and if it inspired your worldview in any way. Thanks for being here. I will see you soon with another interesting mind demystifying another interesting topic. Until then, take care.